In our next section of 2.2, we're going to evaluate limits algebraically using some of our special trigonometric limits. Now, once we learn L'Hopital's rule later on in the course, there'll be another way to do a lot of these limits, especially these trig ones, but let's take a look at what we're looking at today. These two limits are two limits that you might want to commit to memory. I'm not going to go through the proof of these, but you can research them on the internet or in your textbook if you'd like. But basically, if we have the limit as x approaches 0 of sine x over x, or x over sine x, that limit is 1. And the limit as x approaches 0 of 1 minus cos x over x, or x over 1 minus cos x, is equal to 0. So those two limits are special limits for trig, and now we're going to see how to evaluate trig expressions using these rules. So let's look at part A. I'm asked to find the limit as x approaches 0 of sine x divided by 2x. Okay, well, if you recall from our rules of limits, this would really be the limit as x approaches 0 of 1/2 times sine x of x. And now this would be the limit as x approaches 0 of 1/2 times the limit as x approaches 0 of sine x over x. And the limit as x approaches 0 of a constant is just the constant. And this is our special limit. The limit as x approaches 0 of sine x over x is 1. And 1/2 times 1 would be 1/2. In our next example, notice we have the limit as x approaches 0 of sine 2x over x. So this question is a little bit different because the 2 is inside my trig function. So I have to somehow get a 2 in front of the x on the bottom. So what I'm going to do is I'm simply going to multiply the top and bottom of this expression by 2. So this is going to be the limit as x approaches 0, 2 times sine 2x over 2x. And this really is the limit as x approaches 0 of 2. I just got to erase that there because that's pretty messy. So this equals the limit as x approaches 0 of 2 times the limit as x approaches 0 of sine 2x over 2x. Again, the limit of a constant is just a constant times the limit as x approaches 0 of sine x over 2x is 1, and 2 times 1 is going to be 2. All right, let's take a look at our next example, and this one's a little trickier, okay? But the strategy for doing this one is I'm going to try and deal with the numerator and the denominator separately in this case. So what I'm going to do is I'm going to have the limit as x approaches 0. Well, I'm going to multiply sine 7x by 7x over 7x. And I'm going to multiply sine 4x by 4x over 4x. So if I do that, I'm going to get 7x times the sine of 7x over 7x. And I'm going to get 4x sine 4x all over 4x. So now you can see I have my special limits right there. And this is my major division line. So this x can eliminate this x. So I'm going to be left with the limit. I want to really break it up into parts as x approaches 0 of 7 times the limit as x approaches 0 of sine 7x over 7x, all divided by the limit as x approaches 0 of 4 times the limit as x approaches 0 of sine 4x over 4x. And again, we know that these limits both here are 1. And the limits of my constants are just my constants, so my final answer is really going to be 7 over 4. A lot of you probably could have jumped just from this step right to here to see that these are 1, so my answer is just going to be 7 over 4, but I just went through all the algebra for that one. Okay, in question D, I'm just going to erase all of this now. You can look back on the video if you need that. In question D, you have to be careful with this one because this one is not approaching 0. It's approaching pi by 6. So this is a direct substitution. So the sine of pi by 6 all over 4 times pi by 6. Okay, so the sine of pi by 6, if we remember our 60-30 degree triangle, the ratios are root 3, 1, and 2. So therefore, the sine of pi by 6 is going to be the opposite over hypotenuse, because pi by 6 is 30. So this is going to be 1/2 divided by 4 pi over 6. And if we were to multiply by the reciprocal, I would have 1/2 times 6 over 4 pi. Whoops, not 4x, but 4 pi. And if we simplify, I get 6 over 8 pi, which is 3 over 4 pi would be my final answer. And remember, this pi is in the denominator. It's not at the end of my fraction. Okay, in our next example, we have the limit as x approaches 0 of 5 minus 5 cos x over x. So again, with this one, we could see that if I was to factor a 5 out of the numerator, I would get 1 minus cos x. This is all divided by x. So this would be the limit as x approaches 0 of 5 times the limit as x approaches 0 of 1 minus cos x over x. And this is one of our special limits, and this limit here has an answer of 0. This is a limit of 5, and 5 times 0 is just going to be 0. Okay, so there's a few questions to try from your Calc 30 textbook on special trig limits. So give those a whirl and see how you do.